Alright, so today we're going to take a look at how to graph a line when you're given an equation. We're going to look at two strategies, one where we use the gradient and the intercept, and one where we plot 2 points. Okay, so just a quick refresher. First of all, gradient-intercept form of a line is this y equals mx plus c. Okay, it doesn't really matter what letter we use as long as there's a letter before the x and something by itself. Okay. Now in this form, m is the gradient, also known as the slope, depending on the textbook you're looking at, but think of it as the number beside the variable. Again, it doesn't matter whether it's c plus mx or mx plus c, all we care is that the gradient is the thing beside the variable, the number. Okay? And then c is the y-intercept, also known as the lonely number. Okay? So whatever we've got, the number by itself, that's my intercept, and then the number beside the variable, that's the gradient. As I mentioned, often we switch the order of the terms and write it of the form a plus bx. Again, this doesn't change anything about how we graph it. A, in that case, is the y-intercept because it's the constant, it's the number by itself, whereas b is the gradient or slope because it's the value beside the variable. Okay, so that's what we're going to look at. So our first strategy we're going to do today is graphing using the gradient and the y-intercept. So the example we're going to start with is right here. Graph the line y equals 3 minus 4 over 5 times x. Okay, so that's what we're going to graph. To start, we've got a beautiful graph to draw it on below. So I'm just going to highlight these steps we've got over here for when we're given something that the numbers are nice and simple, we've got a relatively small graph, this is a strategy to go for. The first thing we're going to do is identify and put on the y-intercept. Okay, so just add in there, we're going to first identify it and then put on the y-intercept, so we'll put that single point on the graph. Then we'll look at our equation and identify the rise and the run. Then we're going to put our pencil wherever we started at the y-intercept and create a second point by using the rise and the run, repeat if necessary, and then connect with a line. So let's go through those steps for this example here. So if I start, let's go blue, okay? My y-intercept is the number that's by itself, so we're looking at the 3. So I go to my graph, that is a positive 3. I count up 1, 2, 3. Okay, put a big old dot at your y-intercept of 3. Now looking at the equation, I need to state my rise and my run. Okay? In this case, remember, m, the gradient, is the rise over the run. If it's written as a fraction, beautiful, we're all set up. If you're given a whole number, just think of it as the whole number over 1. Okay? So in this case, our rise we're going to think of as negative 4, and our run we're going to think of as 5. So then we go to our graph. Again, start from the y-intercept. So I've put my pen back where I was before, right on that 3, the big squiggle. The rise says negative 4, so I go down 4. 1, 2, 3, 4. The run says 5, so I go over 5. 1, 2, 3, 4, 5. I pop on a new dot. If I want to make a really great line, I can repeat that, going down another 4 and over another 5. Okay. And then my last step is to connect the line. So this is a really important time to use your ruler or a line tool if you have one. I'm going to try right here. Drawing the line through. It is important that you extend your line beyond just the dots. So I don't start exactly at my first dot and end exactly at my second dot. It does continue past that. Okay. If I want to be really great, I put arrows on the end and label it as y equals 3 minus 4 over 5x. So start by putting on the y-intercept, use the gradient counting squares to put on another point, and repeat if necessary, and then connect that with a line. Okay? So that's the first strategy that we've got for graphing an equation given a line.